Okay, so section 2.3 to 2.4, we're going to talk about tangent and normal lines. So, to find the equation of a tangent line, if this is a free response question, you are welcome to leave all of your equations in point slope form, which is y minus y1 equals mx minus x1. Multiple choice, you have to be flexible, and I'm going to leave all my answers in slope-intercept form just because that's what students are used to. So, first, you're going to find the equation of the slope by taking the derivative. Then substitute x to find the derivative into the derivative to find the, I call it the tangent slope. And then we're going to write the equation of the line. And then we put it in slope-intercept form. All right? So, for example number 1, we're going to go ahead and use the power rule to find the derivative. So, 4, subtract 1. Multiply when you bring down, subtract 1, and the 2, remember, has an x to the 0, so when we bring that down, it's going to go away, because that'll be times 0. Now, this is our tangent slope, our general tangent slope. So our specific tangent slope, we know that x is equal to 1. So we got f prime of 1 is 4. So what do we get? 4 minus 6 is negative 2. All right, and so I call that my tangent slope. So then we know our x and we know our y value, and we can write an equation of the line. Oops. So y minus y equals mx minus our x. Okay, and this would be fine for free response. Otherwise, we're going to go ahead and distribute and simplify. Adding 0 won't change anything, so this is the equation of the tangent line. So really, just to give you a graphic display of what we're doing, this is a quartic function. So let's just say it looked like, and this is at 1, 0. I'm totally making this up. The equation of the tangent line is right here. That's what we're finding, okay? All right, so let's look at number 2. We're given a general function, so we're going to use our power rule to find the derivative. This is like 1, x to the first, so 1, bring our power down, subtract 1, we get x to the 0, which goes away. All right? And then x to the 0 is 1. So really our derivative is 3x squared plus 1. X is equal to negative 1. So we get 3 plus 1, and so our slope of our tangent line is 4. Write our equation of our tangent line, y minus y equals mx minus x. 2 negatives make a positive. We'll distribute and subtract 2. And this would be the equation of the tangent line. Okay, now a normal line is similar, but a normal line is defined as the line that is perpendicular to the tangent line. So if I go up here, it's still at the same point, but if that's the tangent, I need to make, I'm going to try to draw as straight as I can. This would be the normal line. Okay, so the point stays the same, our derivative is going to stay the same, but now we need to find our perpendicular slope. So because the slopes of perpendicular lines are, they are opposite signs, and reciprocals, like 5 and 1 over 5, okay? The slope of the normal line is 1 over f prime of x. I don't memorize this because I'm just going to do the opposite side and reciprocal. So everything stays the same except our slope. So first we need to find the derivative of our tangent, which is a power rule. I'm going to find my tangent slope, so I'm going to label that so we remember what we find and we don't forget. So if I plug in x equals 1, I get 4 minus 6 is negative 2. Okay, now our normal slope, this is going to be the extra step. It's the opposite sign, so it's positive, and the reciprocal of 2 is 1 over 2. And then everything else is going to be the same. So y minus y equals m x minus x. We'll distribute, add 0, so y equals 1/2 x minus 1/2. And that's the equation of the normal line. All right, let's do number 2. Same thing, we're going to find our general derivative. I'm going to plug in negative 1. So 3 plus 1, so our tangent slope is 4. So our normal slope is going to be, if that's positive, this is negative, and the reciprocal is 1 over 4. So y minus y equals m x minus x. This one has a little bit more cleanup. So y plus 2 equals negative 1/4 x. That would be a plus, so minus 1/4. And then we're going to subtract 2. So y equals negative 1/4 x. And we don't usually write mixed numbers, but that would be negative 2 1/4. So minus 9/4. All right, so finding a horizontal tangent line. So what does a horizontal tangent line mean? So you have to think, horizontal is this line. And what do we know about that line? Well, we want you to remember that it means that the slope is equal to 0. So since slope is aka derivative, that's going to be our rule. So take the derivative of the function, set the derivative equal to 0, and solve. This could be factoring, trig relationships, anything is fair game. All right, so number 1, these would be your directions. Find where the graph has a horizontal tangent line. Now, if they don't specify and it just says where, then your answer needs to be a point. It might also say find the x value, because that's going to be a little quicker. So you just want to pay attention if this is a free response question. So what we know is our derivative equals 0. So we're going to take the derivative, which is a power rule. So 3 times 1/3 is 1. X squared. There's an exponent, so minus 4. That x would become 0, so the x goes away. So now if I set this equal to 0, you can either factor this or you can add 4 to the other side. And then remember, when you take a square root, you have to remember that it's plus and minus. So we actually get 2 points. So one is going to be at 2 and the other point is going to be at negative 2. All right, so now we need to find out what those y values are. So to get the y values, you're going to plug those into the original. So what do we get? 2 cubed is 8, 8/3, minus 4 times 2 is 8. So what do I get? If I get a common denominator, I would get 24/3. So 8 minus 24 is negative 16/3. Same thing if I plug in negative 2, that makes that a negative 8, and negative 2 makes that a plus. So I get negative 8 plus 24 is positive 16/3. So it really just depends on the question, okay? All right, I'm going to skip ahead and do number 3. So if we find our derivative, we get y equals, this is like x to the first, so bring that down, 6x to the 0, oops, y prime. So y prime equals 6. So there's nowhere, when I set this equal to 0, there's no variable to solve for. So what that means is that never happens. And let's think about this. This is a graph of a line. We go down 4, our slope is up 6 over 1, it's pretty steep, and there shouldn't be any point that has a horizontal tangent line. We need like a parabola so we could draw a tangent line, okay? So no horizontal tangents. Don't leave it blank, don't write 0, write something that says does not exist or no horizontal tangents. All right, question number 2. Is going to be some trig review. So I like to clear off a little space here. All right, so our derivative, well, the derivative of sine is cosine, and we want to set that equal to 0. So we need to remember, well, what did cosine look like? That's pi. So we've got pi over 2, 3 pi over 2, and 2 pi. So cosine starts at 1, 0, -1, 0, 1, and it's just going to keep going. So I know we have pi over 2. So I've got 1 pi over 2, 3 pi over 2. And if I keep going, it'll be 5 pi over 2. We're going to keep going in both directions. So we generally write that as x equals any starting value. And then we're going to add, they're really pi apart. So we're going to add and subtract pi times n, where n is an integer. And there are symbols for integer, z. So n is an element of z, if you see that in textbooks. Okay, this is good enough for me. All right, differentiability and continuity. So this is an alternate definition, and so really you just have to be able to recognize this because it might be used as a multiple choice question. We'll get to that assignment on its own. So for right now, you just need to know, like, okay, it really does look like a slope. So what we want to notice is that the derivative at c of our, that's the notation, the existence of this limit requires that the one-sided limits exist and that they're equal. Okay, so what that means is that we want our slopes to be the same. So if they're not, so we want the slopes to be the same, okay? If the slopes are not equal, so therefore, if the tangent slopes or derivative values at a point, tangent slopes are not equal, then what that means is that the function is not differentiable, okay? So sometimes we use definitions to help explain why something doesn't occur, and that's kind of the more useful portion of it. So one example of that is graphs that have sharp turns. So if you think of the absolute value graph, it's a V. And so kind of just our general working definition is if I want to know at 2, see how there's a sharp point there? Well, I want to look at the slope. So if I would draw like the tangent lines, well, that could be, we've got 1, 1, so this would be a tangent slope of 1. But on this side, these tangent slopes are -1. And so what happens is because our tangent slopes on the left and the right are not the same, it means that this graph is actually not differentiable at that sharp point, okay? So they showed that mathematically by plugging in 2 for our C values, okay? So that's what we're going to recognize later. So since one-sided limits are not equal, we can conclude that f of x is not differentiable. And has no tangent line at x equals 2. All right, so we can have a continuous graph that has no holes, but it might not be differentiable, which means you cannot find the derivative at all values.